you have this. I will not spend any time on it except look at the direct use of geothermal energy by country. And I have both the installed capacity and I have the energy usage or production per year in terajoules, that is to say thousands of gigajoules. And what we have on top is USA in terms of installed capacity for direct use, and Sweden is number 2. I only want to look at these two. And the total energy usage is higher in Sweden. There's a higher load factor. And China, which is third, has the highest load factor, although it is number 3 in terms of installed capacity. And then we have Iceland, so of course we have one Icelander for 1,000 people in the US. So on that scale, it really is important to us. But I want to point out here, Sweden. They don't have any conventional geothermal, no hydrothermal systems. But what has really exploded, both in the United States as well as in Western Europe, mostly within the European Union, is the use of heat pumps. You can really save electric energy with heat pumps, which is like a refrigerator backwards. Instead of cooling a space, you heat up a space by the same technology, which was theoretically pointed out by Lord Kelvin, I think in 1840, and then technologically developed during the Second World War for the first time 100 years later, but it really didn't take off until about 1990. And if you have a heat pump to use your heat instead of using the electricity directly, you save about 2/3. And this is, of course, very important for a world that is facing shortage of energy resources. And Sweden is already, with geothermal heat pumps, it means you drill a well of 100 or 200 meters. You can do it in your backyard. You get slightly thermal water, and you can have a pipe system going into the well like a loop, and similar to ammonia refrigerator. You can compress the ammonia, you can expand it, and you can extract the heat from a cooler body and put it into a warmer body. And this is going to, I think, continue to increase enormously to save on fossil fuel. So if we look at this by the type of use, direct energy by type of use, you can see heat pumps, and now, this was in 2005, it was already on top in 2005, just more than bathing, which is important in Japan, Iceland, Turkey, China. These are the most important countries for using this. And then space heating now is third. Of course, heat pumps is for space heating, but it simply is kept separate because of the technology. And then other uses, they are much less. And again, I show this by country. And you can see that it is quite a few countries that use geothermal energy directly. If we look at it, I think I will skip these. I see the time is running late. This is how installed electric energy has increased with time. It's very close to 250 megawatts per year. Now, important for some countries. When you look at China, we have a large power plant in eastern Iceland, a new one of about 700 megawatts. And to point out how small we are, our population, our country, is China commissions a 700 megawatt power plant, one every Tuesday and one every Friday. That is 1,400 megawatts per week, and it's mostly coal. So this is the increase per year in geothermal compared with just the increase in coal. Our increase in geothermal per year is almost the increase in coal-fired power plants in China in 1 or 2 days. So one must be aware of the scale of these things. And this is how it is by country. For electricity, you can see again the US is on top. It is mostly the geysers in California. There are quite a few in that part of the US. But developing countries come high, like, well, I don't know about Philippines, but it's a relatively poor country. Indonesia is poor, Mexico is poor. So it is an important energy resource for for many poor countries. Let me leave this and now look a little bit at the geology of these resources in Iceland. I've been talking a lot about uses and about the energy situation in the world, but now a little bit of geology. I hope I can keep it simple. On the left, you can see Iceland. It didn't exactly look like this 6 million years ago, as you can see on part A on the left on top. But what this slide is meant to show is the location of two things. The active volcanic belt, where we have the crust is spreading. This is separating the American plate from the Eurasian plate. And then this little circle, which is our hotspot, a mantle plume that goes down several hundreds of kilometers into the mantle, which is a thermal anomaly and a slow upwelling of mantle material, making volcanism in Iceland more intense than to the north and to the south on the mid-Atlantic ridge. So we do not only have a spreading axis, we also have a mantle plume, and this is what makes Iceland special geologically. It really is the only place on Earth where a mid-oceanic ridge is not oceanic in the sense. It comes above the ocean. But then you see what it looks 3 million years ago and what it looks at present. And you can see that this circle, the mantle plume, is really migrating to the east. The volcano which is erupting now is here. This belt here, we have one in the north. It is also here, but it was in a different place. It was really here 6 million years ago. And this volcanic belt is now splitting into two in the south. This one is retreating, and this one is expanding south. Well, we have this big volcano, and the eruption is more like what you see like in Philippines or St. Mount Helens. It's pretty explosive. It's not just smoothly flowing lava that you usually see in Iceland like in Hawaii. And the reason is that about here, this is the end of crustal extension. So the volcanic activity starts first, and then this extension of the crust or spreading of the crust comes a little later. So